The hot topics and latest news is a section of our Vienna deep learning meetup that we introduced a long time ago to report always on interesting new papers, literature, software, and different things that came out from 1 month to the next, as deep learning is such a fast-moving field. And usually it's someone of our co-organizers who presents some hot new topics, but we actively ask our community to contribute to this because we can never observe everything that is going on in deep learning. So if you come across something really exciting, something really interesting, please send it to us, or you may also prepare 1, 2, 3 slides yourself and present such interesting things that you found around deep learning. This time, René has prepared some topics following the NeurIPS conference that is going on this week, but we also have Pieler here who presented earlier some hot topics already. And let's see what René and Michael want to present us today.
Yes, can you enable my screen sharing? It says I cannot share my screen.
I switched to multiple can share. Yeah, can you try again?
Yeah, excellent. Cool, thank you very much. So yeah, hot topics and latest news. Not a very long one today. Basically several pointers and a presentation by Michael. As you have probably seen in the news, DeepMind published their AlphaFold 2 paper, which is heralded as one of the biggest breakthroughs in the last couple of years, both on the machine learning side and especially on the protein folding prediction side. It is quite a dense topic, and I guess most of us will not have a background in biochemistry, neither do I. I found a very nice summary by Lex Friedman, perhaps you know him. On YouTube, just Google his name and you will find the very good summary. So basically, just to give you a brief overview of what it is about and what's the impact of it. So basically, it's about protein folding, meaning it's a mapping of like this amino acid chains or protein amino acid sequences. And given this sequence, how to predict the 3D shape of the resulting protein, because that's what defines its properties when it's in the body. So that's the task. It's a prediction task. And what is the big thing about it? It was often quoted in the popular press that it solves protein folding. It's not a mathematical problem per se. So like solving means that it got a very good score in a benchmark. So basically the better way to phrase it is that it's like we had ImageNet on the computer vision side, where basically deep learning suddenly took over the existing methods or took over the field by beating existing methods. That's basically similar now for this protein folding. So you can see here every year or every 2 years, they have this benchmark competition. And already 2018 AlphaFold, the first version, achieved a very high score. And now AlphaFold 2 got a score which was unthinkable. And basically that's why it said it solves this problem. It's not a perfect prediction, but it's really like this really big breakthrough. Main difference between AlphaFold 1 and AlphaFold is like AlphaFold 1 used convolutional neural networks and AlphaFold 2 used attention mechanisms, transformers, which coming from the NLP field are also taking over image processing now. And as we see here, also works with this really, really well. Again, just a pointer, check out the video. He does a much better job than I could ever do. The second thing I want to point you to is NeurIPS 2020. It's currently going on. It started on Sunday and will be going on till 12th. I guess everybody knows it. It's the largest AI conference there is. Really exponential growth. It's pretty insane, actually. It would have been here in very lovely Vancouver if you ever had the chance to go. It's fantastic. This year, virtual, obviously. The upside of that is that it's much cheaper to attend because you don't have to go there. It's just $100. And I can really recommend checking it out. It's really an amazing array of not only papers, because those you could see from arXiv or somewhere else as well, but it's really like the presentations, the keynotes are very, very interesting. And there are a lot of tutorials, which basically you don't have any other chance to see or get access to. That's actually quite a good thing to about NeurIPS that you can see those there. The format is that you have like a very nicely organized schedule. It's pre-recorded videos, so you can watch everything whenever you want. But there are time slots where there's basically a live presentation where there's a chat going live next to the video, so you can ask questions there. So yeah, I think that works quite nicely. There's also workshops at the end of the week, so that might actually be a bit more easier to manage because there are, I think, 1,900 papers this year accepted, so it's just very difficult to get a grip on it. The workshops might be easier to survey. There might be like 20 workshops, 30 perhaps, so it might be easier to like focus on the topics you're interested in. That being said, it's a lot of material, and the next deep learning meetup on January the 13th, we will do a NeurIPS review, trying to figure out, okay, what's the 2-3 most important trends at the moment. Perhaps we can group them and pick something out. So now I just want to highlight 2 keynotes and 2 tutorials which might be of interest to you. Usually these invited talks, it's very interesting. They often try to invite people who are not like really deep in the trenches of like improving networks or something, but like give more of an outsider perspective or a bit more of a social component to the questions. One of the 2 is this one here. It sounds a bit more like, oh, this is engineering, what's this all about? But it's very interesting, the analogy being drawn, because, for example, if you think about the airline industry, when there is a plane crash, then the investigations there are very thorough and they are shared publicly with everybody, which is very interesting. I don't know of any other industry where like if something goes wrong that you really have like this super intense investigations, like from the specific country, from the manufacturer and so on, the airline. And that gets shared with everybody to improve the overall state of how aviation works. And that's very unique. I don't know of any other industry that does it like this. And if you compare that with software industry, for example, okay, it gets a bit better if there's a major breakdown of AWS or whatever. You would see those postmortems a couple of days later to like, so they tell you a bit of what went wrong so that you get a better understanding, but they might not be that in depth, so they might not really allow you to perform better yourself in the future. I'm not quite sure. Usually those postmortems are not that good. And here's an argument being made for like, especially in this world of AI, currently stuff gets deployed, make some predictions, basically fast and loose, just like get stuff done and boom, advance whatever your application is doing. And here's really the case for like that we should do this more principled, figure out when we break stuff, how to better deal with this, and also like how to share the knowledge and do it better as a community. So interesting talk on that side. And the other is, again, what I meant, this like the social aspect of the entire field of AI for the world. Yeah, like behind most of the deep learning approaches you see, that stuff gets annotated. And the question is by who? I mean, like we all know reCAPTCHA and we click on all the lampposts and the cars and so on. So like we are annotating stuff. But for many, many other domains, you have like these invisible worker pools hiding somewhere behind Amazon Mechanical Turk. So take a look at their lives, situations, what this type of work means for them, how this entire field of work will look in the future. That's the topic of this talk here. 3 more highlights or things I want to show you. In the tutorials, again, as I said, tutorials are really a unique aspect of these conferences. Because it's virtual, they do it a bit differently this time. You have the presentation track, which is quite long actually. And there's additional Q&A sessions on different time slots later on. So to give everybody in all time zones a chance to post questions. Yeah, federated learning was a hot topic in the last 2-3 years. If you've never heard of it, it means basically you don't have to gather all your data in one data center, so to speak, or one computer to train your network, but you can leave the data, for example, in a medical setting, in the hospitals. And inside the hospitals, you basically perform a bit of the training and just exchange the weights. So distributed geographically or organizationally, you train in a distributed fashion and never have to share your data. Might serve with privacy, for example, in a medical center. So that's federated learning. Very hot topic in research last couple of years. And here it's really like industry meets academia is like, okay, how do you actually use it in practice? One great federated learning showcase is, for example, if you do like swipe type prediction on the phone, on an Android phone, it learns, it predicts something, you change what it predicted because you don't like it. And this will be used to learn an even better prediction model. And this actually really trains on the phone. And if you're at Google or Apple, you can do that with a couple of million phones, hundreds of millions of phones. So even if we only do a little bit of training per each phone, so not waste too much battery, overall, these systems get much, much better. The second one, yeah, explainability of machine learning algorithms. You know what it's about. Over the state of the art. So if you're trying to get into the field, definitely valuable to check that out. And the last one is conversational AI, chatbot, so to speak. If you're trying to get a grip on what's going on in that field, definitely that tutorial would be for you. Yeah, as I said, we will do a review of all of NeurIPS in January, and yeah, hope to see you then. With that being said, yeah, let's move on to the next presentation, which is by Michael. I guess you want to present your screen yourself?
Yeah, I prepared everything.
Cool.
So just a second. Can you see my screen? With the slides too?
Yes.
Yep, perfect. So yeah, recently I stumbled over this interesting paper, and it's called Exploring Simple Siamese Representation Learning. And it's a very interesting paper which builds upon other self-supervised learning approaches I will just briefly mention on the next slides. And it's by Xinlei Chen and Kai-Ming He. And Kai-Ming He is also the guy from the He initialization and from the ResNet paper. So quite a deep learning all-star. And the abbreviation for the setup is then SimSiam, and I will refer with that name to it. But yeah, before we go to the SimSiam approach, first I will show you like a brief overview why it's an interesting approach and what was like the before. And the thing a couple of months ago, which like got a lot of traction in this self-supervised learning space, was the simple framework for contrastive learning, or SimCLR. And in a nutshell is there you put in an image like the dog image, generate two different augmented views, and you want to, in the output space, you want to, during training, you want to generate a vector representation where those two views, so this grayish dog image and this reddish one, are close together and are very far from other images like the chair here. And with that setup, you need a lot of images, and you need a lot of positive, or you have one positive example, or you can even have several ones, and you need a lot of negative examples. And we will see later on where this comes into play with the SimSiam approach. Then another thing which also worked quite nicely was the bootstrap your own latent approach. This is where you kind of have one network, or a network in full backpropagation mode, and the other one is like updated in a moving average fashion, like a momentum update. And then you have something like a stop gradient operation here, and you compare those two representations with each other. And another thing which was then better than the two before was the swapping assignments between views setup. And this is kind of similar to the SimCLR approach I have shown before, but uses a different setup for assigning the vectors, and then makes this kind of swap which you see now and compares those. And kind of this setup was then one of the most complex, maybe. There are a lot of other setups here. So when you look into the literature, you will find a lot of other fancy different names. But those three, I guess, were one of the major ones. And interestingly, in the SimSiam paper, they found out that actually you can cut away a lot of the features from these previous approaches, namely the negative sample pairs. So you just need the positive samples. You can reduce batch sizes a lot, and you can also get rid of the momentum encoder. And when you look here now at this model layout, you see you have here your encoder in full backpropagation mode. You add on top like an additional predictor network, or I guess it's usually a multi-layer perceptron they use. Then you have your similarity score. And the only thing you change here is that you have here this stop gradient operation. And surprisingly, with removing a lot of the features from the previous approaches, it was still working as good or sometimes even better. And in the paper, they argue a little bit how that can be, but still there is no final solution to that. But I guess what's very interesting is also the pseudocode, which is like almost PyTorch code, and you see it's actually quite tidy and quite clean, and yeah, not a lot of lines. And what you see here is the loss calculation here, and yeah, the only tricky part is here maybe this detach, where you like introduce this stop gradient operation, and then you do a vector normalization, and yeah, that's it in the end. And I guess it's like very, yeah, kind of, you always expect a lot more, but actually it's quite tidy and clean. And here you have also the comparison to the other methods I outlined before. And what you see here in red is the interesting part, which can get rid by the SimSiam approach. And yeah, and this is what they also argue in the paper. It's kind of very interesting that this approach works. And but they still have no kind of theoretical really well-based explanation why it works at all. And it's kind of also the question what gets optimized in the setup at all. And I guess it's very interesting because, yeah, it's super simple and works quite nicely. And this is what I can show you here on the last slide. So here you have the other methods. Here, for example, you see the batch sizes that some methods need. So we're talking here about batch sizes in the range of thousands. And you see that the SimSiam approach, when you compare it on ImageNet linear classification, is comparable to the other more complex setups. And also the transfer learning capabilities are quite similar, or sometimes even better. So I guess it's a very interesting approach. And yeah, will be very interesting, I guess, what will come after that, because I guess there's still a lot to find out on this like self-supervised learning path. Yeah, and with that,
thanks a lot.
I'm at the end of my slide deck.
Quick question, Michael, the predictor, what does it predict? Because you have like two encoders. So at the end, you have like the two feature vectors. What does predictor then do?
The predictor is just another transformation stage.
Okay.
This is kind of an implementation detail they first introduced in this SimCLR approach, and they found out when they used the representation before this predictor had, it's usually better than afterwards.
Okay, need to check it out.
But it's needed also for the setup with the SimSiam. Okay. In the SimCLR approach, they found out that this is kind of beneficial if you use the vector representation before this multi-layer perceptron had. And in the SimSiam paper, they even check the contribution, if I remember correctly. They kind of make an ablation study, what's needed, what's not needed. And the problem in the SimSiam approach they sometimes then encounter is that the stuff doesn't learn at all, something reasonable, so it stays at 0. And when you have this predictor in place and this stop gradient operation, it suddenly learns very, very good, which is kind of, yeah, maybe not to expect, yeah.
Cool, thank you very much.
Great, thank you very much, Michael and René. Yes, are there maybe other brief questions for these hot topics? Obviously, we cannot go into detail here because we are not the authors of these papers, but if there are some questions, let's have a moment to see if anyone needs clarification here. If not, then let's conclude the hot topics section of this 36th meetup. And René, there is another you wanted to repeat an announcement, if I'm correct.
Exactly. So yeah, we had the giveaway, and I had prepared a very nice random number generator to figure out who won. But we only got one submission. So the winner is IJ. I don't know more than you do. That's the name that's in the email. So yeah, congratulations, and I'll send you the link to sign up for the conference.
Great. Okay, that goes fast. Yeah, quick ticket out here. Yeah, that's why it's worth to attend our meetup directly. This time we also recorded. We will figure out where to place the slides and the recording. So the slides go usually on our GitHub page that I mentioned in the beginning. We're gonna post this one in the chat as well. And we have already a date for the next meetup, January 13th. It's gonna be a virtual edition again. And René gave you practically a teaser here about what's going on in the NeurIPS conference, the world's largest AI conference that is taking place this week. We will take time to distill this. And in January, we have planned a big NeurIPS review with really the best of hottest AI developments coming out of that conference. Yeah, René, do you want to say any word about this?
Not more than I already did. Yeah.
Okay, thanks for that. There's also a meetup link here. So the event is not online yet, but we will post it soon. So please sign up for it in the RSVP so you don't forget that date. You can note the date already. And yeah, this is where our 36th meetup concludes, except for the networking session. So we would appreciate if those who want to have chats among the community would stay. We're going to segment this into different breakout rooms, and yeah, hopefully see you there for some chat around what you are interested in deep learning, what your problems are, and maybe you find someone that can answer your questions or join your team or solve your problem. So yeah, hopefully that works out for you, and see you at the next meetup in January. Have happy holidays.